the diffraction point. So question is, at a point on the screen directly in front of one of the slits, find the missing wavelength. Now, let me explain you what exactly I want to ask, and then we'll continue. No? So suppose this is your double slit plane. This is your screen. And what have they said in the question? It directly in front of one of the slits. Let's say point P, which is exactly in front of. Acha, ha, I gave you one question similar to this, right? Were you able to do this? Guys, I gave you one question, one or two questions in the last class as a homework. Yeah, I gave you, we wanted a third bright to form at this particular position. So basically for the third bright, can you see this distance y of third bright? The distance of third bright from the central maxima, this should be equals to d by 2. So basically बस यही condition follow करनी थी, and that is what you needed to solve. So 3 lambda d by d is equals to d by 2. So from here, can you see over here? D square is equals to 6 lambda d. D square is equals to 6 lambda d, and d is equals to under root of 6 lambda d. So you put lambda, you put d over here, and you get your answer. Is it clear? Easy था ये तो, है ना? The question was easy, right? Sorry. Now they wanted to ask what are the missing, find the missing wavelength. Now what is the missing wavelength? Missing wavelength is basically the wavelength which we cannot see, we can't observe, right? Or see. So basically at point P, if they are asking what are the missing wavelengths, it means that you need to find all those wavelengths for which the intensity is 0. Are you getting my point? If the intensity is 0, will you be able to see that particular fringe over there? Right? That implies at point P, a destructive interference should happen. So, ये missing wavelength से you need to analyze all this. This is the first type of question which I am giving over here. So that's why I told you everything. Okay, what does missing wavelength means, and should happen. Now, if destructive interference is happening at point P, then can I say this particular thing that at point P, the path difference should be equals to 2n minus 1 by 2 into lambda, right? Yes or no? Can I say this? Point P pe, and what will be the position of this nth dark fringe over there? I'm putting a general dark fringe. Any kind of dark fringe can form over here. There can be first dark, second dark, third dark, whatever dark can form at this particular point. So that's why I generalized it to nth dark. So now what will happen? This nth dark, the position will be equals to what? 2n minus 1 by 2 times of lambda d by d. If you remember the formulas, right? ऐसा formulas कभी नहीं भी लिखो तो can you see this is delta x into capital D upon small d is basically your y, right? This position, where do they want, guys? Where do they want a dark fringe? At point P. So again this distance is d by 2, so I can solve it. This distance will become what? D by 2 is equals to y nth dark, and this should be equals to 2n minus 1 by 2 times of lambda d by d. So again, guys, you can solve it from here, right? What do you want? You want the wavelength. So lambda is equals to d square. This 2 and this 2 will get cancelled out, divided by 2n minus 1 into capital D. Yes or no? Will this be your wavelength? Will this be your wavelength? Where what is n? N is basically 1, 2, 3, 4, and so on. So if you put the values over here, you'll get lambda equals to d square by 2d for n equals to 1. For n equals to 2, you'll get lambda equals to d square by 3d. For n equals to 3, you will get d square by 5d, and so on, right? So basically for d square by, sorry, this will not be 2d, this will be d only. So d square by d, comma, d square by 3d, comma, d square by 5d, and so on, wavelength will be missing. Guys, understood missing wavelength का concept? You understood the concept of missing wavelength? Wherever there is a missing wavelength, it means a dark fringe is forming at that particular point. It can be any dark fringe. So that's why a general case and this whole question. So लिख लो. कौन आ रहा भाई? Guys, done? Guys, are you done? Okay. So 100% again. Please write the next heading. The maximum order of interference fringes. Now, guys, tell me the pattern which forms on the screen, will it extend till infinity or will it extend to a finite number? Right? Tell me this particular thing. The pattern which forms on this thing on the screen, does it extend till infinity or does it form till a particular number? It does not form till infinity. It forms till a finite number, and that number is basically equal to what? Maximum order of. So basically, this is what it is: the maximum possible value of n for a given YDSE setup. So basically, n की जो maximum possible value, that is basically what, है ना? I've now see this particular thing, guys. We know in Young's double slit experiment, we know there are two formulas which are there. One is basically sine theta is equals to delta x upon d, and the second formula is basically the one which is for y, right? Yes or no, guys? Hello. Although we don't need that, but still. इतना क्लियर है? साइन थीटा इज बेसिकली इक्वल टू डेल्टा एक्स. अब if I say for a bright fringe, from here can I write this thing, delta x is equals to d sine theta. Okay. So if I say for a bright fringe, any general bright fringe, if I talk about, will delta x be equals to n lambda? Yes or no? So can I put this n lambda in this equation? So I can get n lambda is equals to d sine theta. So from here I can say n is equals to d sine theta by lambda. Can I say this? Yes or no?
Yes, sir.
Ab, if I want the maximum possible value in a given YDSC setup, this d and lambda are going to be constant. What is the only thing which is variable? This theta, right? So what is the, if I want this to be max, even I need to max my sine theta, right? And what is the maximum possible value of sine theta? When theta is 90 degrees, sine theta is 1, and this is basically the maximum possible value of sine theta, right? So in place of sine theta, I'll put 1, and in place of n, I'll put n max over here is equals to d by lambda. लिख लो. For a bright fringe, this is the maximum possible value of n. Is it clear? Easy concept है, ज़्यादा इतना difficult नहीं. It's an easy concept. Yes or no? N max is basically this. Now similarly, for a dark fringe, the value of delta x is basically 2n minus 1 by 2 into lambda, right? Yes or no, guys? Yes or no? Can I rearrange it something like this? N minus 1 by 2 into lambda. Can I rearrange it like this, guys? Hello? If I can rearrange it like this, then can you see over here? I can write delta x is equals to d sine theta. So in place of delta x, I'll write this. So n minus 1 by 2 into lambda is basically d sine theta. I'll do it exactly the same, just like previous case. So can I say n minus 1, or can I say n is equal to d sine theta upon lambda minus 1 by 2? Oh, sorry, plus 1 by 2. Can I say this? Guys, can I say this?
Yes, sir.
है ना? So from here, if I want the maximum possible value of n again, if I want to max this, then ये तो constant है, इसको तो कुछ कर नहीं सकता हूँ, ये दोनों experimental based है. So again, what will be the maximum value of sine theta, right? So here for n max, I'll write this is equals to d by lambda plus 1 by 2. This is,
Sir, can you
हाँ जी,
scroll up a little?
हाँ, sure, till this.
Yes, sir. Little more down. Yeah, thank you.
So basically this is the value of n max. Is that clear?
Yes, sir.
लिख लो. This is for dark fringe है ना, थोड़ा सा ध्यान रखना. This is for dark fringe. This is the maximum possible value of n for a dark fringe. अच्छा, if someone says कि अच्छा ये sir, what will you do after finding out the maximum possible value of n? I can count the number of maxima, I can count the number of fringes found. The total number of maximas in the pattern is equal to twice of n max plus 1. Can anyone explain me why? Analyze according to you why it is twice of n max. See, n is the maximum order of the fringes, right? Yes or no? So the same order, the same pattern which forms up, the same pattern forms downward down the central maxima as well, right? So that is why we did twice. Why is this twice? Because the same pattern which forms upward, the same number of maxima which forms upward, the same number of maxima will form down the pattern as well. And why are we adding this plus one? This plus one is for, and I'm just counting. Suppose, guys, suppose if I have a pattern here, let's say first dark, then first bright, then second dark, and second, and let's say so on. It goes on. So if I want to count out how many number of bright fringes were there, so can you see? Suppose n max is, let's say, 3. Suppose in case uh, first bright, this will be second dark, this will be third bright, and so on. So guys, can you see over here, if I want to calculate the number of bright, so can you see it goes on, it will go on till n max. The same will go on till, the same will go on in downwards as well. So can you see? That is why I did twice. And here at point O, there is another central bright as well. That's why I added a plus one. So if someone says ki what is the total number of maxima which is found in the pattern, so then you will say it is twice of n max plus 1. Whereas what is the total number of minimas which are found? Is there a plus 1 in the case of minima? Is there a plus 1 in the case of minima? No, right? जितनी आपकी bright बनेगी उतनी ही, for every two brights there will be one dark in between, right? So the total number of minimas in the pattern will be equals to twice of n max. It won't be having a plus 1 over here. Is it clear? Guys, is it clear?
Sir, can you repeat why there is no plus one?
Because there is no central dark with a plane wavefront, right? Incident, when the incident wavefront is plane, there is no there is no central dark. Always there is a central bright, right? So in the case of central bright, because to count this number of maxima, you need to add the central bright as well. So that's why.
Okay, sir.
ठीक है, लिख लो ये. एक क्वेश्चन देता हूँ, then it will be making much more sense to you. एक बार in a YDSC, the distance between the slit and the screen is given 1 meter. The slit separation is given 1 mm. And lambda जो दिया है, it is 0.5 meters. I know the lambda is very high, but it's okay. Doesn't matter. Now see this particular thing, guys. Lambda is very high, and they are asking a find the distance between first and central maxima. Second, find the number of maximas and minimas obtained on the screen. सबसे पहले तो guys always remember this particular thing. Can you see this lambda is very big? अभी तक जितने भी experiments we did in which what was happening, the lambda was small. Yes or no? Was the lambda small?
Yes, sir.
Hey guys, एक second. Oh sorry, my bad. This is equals to 0.5 mm, है ना? But still it is very big. This lambda is still very big. But generally, what we have seen the lambda we have seen in the order of what? 10 to the power minus 6. Generally, it is given in 4000, 7000 angstroms, right? So 10 to the power minus 6 के order में देखिए अपन. But here the order is this wavelength is big. If the wavelength is big, then please be careful how will you use the whole thing, है ना? You cannot use this thing. First of all, first let's calculate nmax. Nmax, can you see guys? We know this particular thing for bright fringe. It is, guys, for bright fringe, number of bright fringe. For bright fringe, it is d by lambda, right? So d कितना है? D is 1 mm. Lambda is 0.5 mm. So can you see only 2 is there, right? So 0.5 mm divided, 1 divided by 0.5 is only 2, right? So can you see the maximum order is basically 2. If the maximum order is 2, then can I say this particular thing? Sir, the central bright will be formed over here. Since you made the wavelength big, this second n equals to 2, the second bright will be formed at infinity. Yes or no? Guys, Ayana, the second bright will be formed at an infinite distance. Yes, मतलब बहुत दूर स्क्रीन के बाहर बनेगा, at 90 degree बनेगा. This will form at theta equals to 90 degree. Are you getting my point, guys? But what about, can you see in between the central bright and the second bright there should be the first bright somewhere? Yes or no? In between this first bright there should be this first dark, and there should be somewhere the second dark. First dark and second dark. Guys, are you getting my point? So how many bright
Yes.
fringes are there over here? 1, 2, 3, 4 and 5. So can you see the second part of the question? If I want the number of maximas is basically twice of nmax plus 1, which is basically 5. Can you see? Nmax was basically equals to 2. Yes or no, guys?
Yes.
So basically this was the total number of maxima. And can you see how many number of minimas were there? 1, 2, 3 and 4. So basically by counting or by using formula, it's up to you, whatever you want. And if this nmax like comes to be 2000, 5000, then then it's a big deal, है ना? तब तो ऐसा draw करके नहीं बताएंगे, right? Then we won't be able to draw it. When the nmax is small, then you can draw it easily. So this will be 4. It is equals to twice of nmax, and this is equals to 4. So this is the answer for your second part of the question. Is it clear, guys? Is it clear?
Yes, sir.
Now they are asking what is the difference between the first and the central maxima. So basically they are asking this length, right? They are asking what is the distance between the first and the first bright. So can I say this is basically the position of the first bright, right? So can I use this formula? A is equals to y1b is equals to n lambda d by d. Can I use this formula? Guys, can I use this? Can I use this formula? Hello?
Yes, so we can.
Because theta will be large. Theta will not be small. Can you see this theta, guys? This angle will be large. So hence you cannot use this formula in this case. So what to do then, sir? You need to go to conventional methods. Delta x by d is equals to sine theta, and y by capital D is equals to tan theta. Is it clear? Now For first bright, can anyone tell me what is the path difference for first bright? Yes, guys, for first bright, what is the path difference? The path difference is basically equals to lambda. पता है कि नहीं? First bright it is lambda, second bright it is 2 lambda, third bright it is 3 lambda, and so on. So delta x equals to lambda for this, and hence I can write d sine theta is equals to lambda. And from here sine theta will be equals to lambda upon d. Lambda is 0.5 mm and d is 1 mm. तो ये कट मारेगा and this will be 1 by 2. So when is sine theta 1 by 2? So can you see, guys, theta equals to 30 degree. That is the reason you can't use the approximation. Is it clear? Guys, you understood why we not use that formula? Because theta is large. After sometimes you will get this, practice. You will just see the question and you will understand कि हाँ, in this case theta is large or in this case theta is small. है ना? Only this will come from practice. Acha, by the way, I have sent one app in the group. Have you seen that app, guys? The HC
Yes,
Verma
sir.
app. So basically, for those students who don't have HC Verma with them, it's for them. You will get the questions as well. So lots of questions. For every chapter, there are questions at the end. Exercises are there, and even the solutions are also there for those exercises. So kindly start solving. I want you to solve the questions. Number of questions जितने ज़्यादा बढ़ेंगे उतना ज़्यादा your exposure towards this subject will be increasing. So always remember that is necessary. So anyways, so you wanted to find out what is the position of this first bright. It will be equals to d tan theta, and it will be equals to d into tan 30 degree. And what is tan 30? And d कितना दिया 1 meter. So from here it will be equals to 1 by root 3 mm. Oh, sorry. This will be the position of the first bracket, and that's the answer to your first part of the question. Understood? एक बार go through the whole question. And I'll give you one question for homework. Now we'll be starting. One question will be given for homework. अच्छा हाँ guys, एक मेरे को बहुत अच्छा point समझ में आया. Suppose this n max, if it is an integer, then it's fine. What if n max is not an integer? It's a let's say 107.66. Guys, suppose the value of n max comes to be 107.66. Suppose in decimals, then what will you deal with this decimal part? Will you round it off to 108 or will you keep only 107? Tell me. From the formula, n max is equals to d by lambda, right? When you solve this d by lambda, it is not necessary that it will always come to be what? Huh? Integer, right? It can be in fractions. It can be in decimal point, right? So what will you do? Deal with the decimal point. See, if it is 107.69, suppose, so this 69 at the end of the decimal, see, 108 was never found, right? N max equals to 107.69. Enough. Suppose so this 69 107 formed. This you are sure shot 107 was formed at infinity, right? Because this is the maximum possible value. What about this 108th for n equals to 108? Did 108th bright fringe formed or dark fringe formed? It's not formed. So basically, whenever it is in decimal, neglect the decimal. only consider this. Is it clear?
Yes, sir.
ठीक है, ये वाला पॉइंट याद रखना. If n max is in decimal, then neglect the decimal, only consider the, or take a greatest integer function. Maths people might be knowing it. ठीक है guys.
So in this question, because they asked about the first bright, we're finding n max of they used the formula of finding n max of bright, and then we use maximum minima. So if it was
हाँ
for dark, then we would use the formula for dark. Is
हाँ,
that how it
yes,
works? Yeah.
yes, this is how it works. And they have given the value of lambda, which is very comparable to the d. See, lambda, it is comparable to d. This lambda, it is comparable to d. Can you see over here? So whenever
Yes,
this
sir.
happens, no, so दिमाग में आना चाहिए. I'm giving you the trick by myself. So whenever lambda is comparable to d, lambda is comparable to small d, है ना, not capital D. Capital D से तो
Yes,
बहुत
sir.
छोटा. But lambda is comparable to small d, then always remember the angle will be large. The angle will not be small, so you can't use that formula directly, है ना? So directly from the question itself, you can compare it with the help of this. If lambda is given like 10 to the power minus 6 meters, or in the order of 10 to the power minus 6 meter or something angstrom, then yes, then you can use that formula and directly you will get your answer, right? Is it clear?
Okay, sir. Yes, sir.
A question for homework I am giving you. Monochromatic light of a wavelength 5000 angstrom is used in YDSC with d equals to 1 mm, capital D equals to 1 meter. Now the question is, if the intensities of the waves at the two slits is I1 equals to 4 times of I0 and I2 is equals to I0. So can you see guys, the intensities are not equal now. Intensities are different. So don't use that formula 4 I0 cos square 5 by 2, right? Don't use that. Now if the intensities are different, find first the fringe width beta. So fringe width, does it have any connection with intensity? No. Fringe width dependent upon lambda d and d, which is constant. So you can calculate this, right? Yes or no? The second formula is basically the distance of fifth minima from the screen. So this is also calculatable, right? The third point, intensity, you need to find out the intensity at y equals to 1 by 3 mm. So basically at this position, you need to find out what will be the intensity. This part may give you a little bit trouble, but it is solvable, है ना? You need to find out distance of the thousandth maxima from center, and last is the distance of 5000th maxima, है ना? Although please remember, एक last part तो मैं ही कर देता हूँ. First thing first, what will you do? You'll check nmax. Nmax is equals to d by lambda for bright fringes, right? Yes or no, guys? Nmax is basically
Yes,
equals to d
sir.
by lambda for bright
Yes,
fringes.
sir.
D is basically given how much? D is 1 mm. This is 5000. So D is 1 mm and this is 5000 angstrom, right? So this will be cutting with this minus 7 1 2 3, so minus 3, है ना? When it will go up, it will become 1000. So 1 by 5 multiplied by 1000 is basically 2 100, राइट? एक सेकंड, कुछ गड़बड़ कर रहा हूँ क्या मैं? हाँ, सॉरी. When 3 zeros will be gone, it will be 10 to the power 4 to 10,000, so it will be 2000. So guys, can you see n max is basically 2000. तो जो maximum है वो 2000 है, and am I talking about 5000th maxima? तो ये 5000 maxima possible? So E part में डायरेक्ट मैं आंसर लिख देता हूँ, 5000th maxima is not formed, non-existent. Is it clear? Guys, are you understanding my point? See, n max was 2000. Nothing can be greater than the maximum value, right? Higher. So basically, this is one of the questions which you need to do as a homework. So, anyways, guys, is this clear?
Yes, sir.
ठीक है. After this, leave 10 pages. 10 names, leave more only. एक second, let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 16, 17, 18. In my notes, it is 18 pages. So you leave approximately 12 pages. 12 to 13 pages complete, both sides. That is for advanced stuff. Okay? In that particular case, what we will study in that case is, it's like what is the effect of changing the direction of incident light in YDSC, what is the effect of introducing a thin film of some material in between YDSC, then uh, there is optical path का एक concept है, then there are some questions which are there, concept of Z value, then use of white light, what will happen if you use white light in YDSC. ठीक है? So guys, are you getting my point? There are still a many things, many lot of things are which are there for J advance, है ना? Which अभी के लिए I am skipping. I have taught you till mains level as of now. Mains and NEET. Is it clear? Guys, is it clear? I am focusing mainly on the mains and NEET
Yes.
part as of now. So I have not focused any part of advance as of now. Is it clear? So with this thing, leave 12 pages after this. है ना? Leave 12 to 14 pages for J advance. Is it clear, guys? So with this thing, I'm done with the interference part. Now let's start with the diffraction part. So heading. Guys, please write down heading diffraction of light. Interference is over till JEE mains and NEET level. Advanced, I'm skipping it for later. मेरे पास टाइम भी नहीं क्योंकि है ना. So now guys, what is basically the diffraction phenomena? See, whenever light, write down, whenever light passes through edges or basically sharp corners of an object, whenever light passes through the edges or sharp corners of an object, then it flares out in the shadow zone. Don't worry, I'll draw a diagram. है ना? So this bending of light around the edges of obstacle is called as the phenomena of diffraction of light. So suppose guys, basically what do I want to say is the like, अच्छा पहले definition लिख लो. Once you're done with the definition, then tell. अच्छा guys, give me 2 more minutes. ना, I'll be just done. So guys, see this particular thing. Suppose if I have a slit in which I have drawn a very small, not a small, big hole. So guys, can you see a slit over here? So suppose guys, if I have a source of light, let's say bulb hai, kuch bhi hai. So suppose if I have a screen over here, can you tell me how exactly light will pass through it? If this hole made is big as compared to wavelength of light, है ना? So suppose if I have a wavelength, source over here, this source is let's say glowing. So basically what will happen? You know, this light ray will pass through the edge of the source and it will look like this. And similarly, this light, another light ray will pass like this. And guys, can you see over here, on the wall there will be this light spot which will be forming, right? Yes or no, guys? So this will be the illuminated zone. This portion will be illuminated, whereas the remaining portion, can you see the remaining portion? This portion will be dark. Yes or no? So this dark portion is basically called as the shadow zone. Okay. So whenever there is a big object over here, then what will happen? This will be the shadow zone. Similarly, the same way how shadow is formed, right? So suppose if you have an object over here, and let's say if you have a source over here, so in this particular case, if I place a screen over here, will this be the shadow region? And will this be the illuminated region? Yes or no? ये अपने को सबको पता है ऐसा होगा. Yes. Here the object is basically bigger. Now what is happening in this case, guys? ये थोड़ा सा एक ध्यान रखना. If this whole or this object is very small, just for example, suppose if I have sharp corners of an object, right? So whenever any object has these sharp corners, the size of these objects are very small, right? Yes or no? The size of that sharp corner is very small. देखा है कि नहीं देखा है, guys? Hello.
So I have a doubt.
Yes, tell me.
So in the first example, you said that the inside one is illuminated and the outside one is shadow, yeah?
हाँ, because this is the hole, this is cardboard. This is the cardboard and this is the hole. Right? Here, this is the object. So I'm giving you two different cases. In this case, basically I have placed an object in which there was the hole was over there. So wherever there was the hole, the light can pass easily, right? And the light, when it
Yes,
passes,
sir.
it forms the illuminated region. And from where the light cannot pass, it forms the shadow region, right? Similarly, in the case of here, there was an object placed over here. So whatever light which was falling on the object, that's why it could not go on the screen, and hence a shadow is formed. Whereas those light which are going above from this particular thing are forming on the screen, and hence that region is basically the illuminated one. इतना सबको समझ में आया? This is all. This is happening when the size of the object is basically very big as compared to wavelength of light, right? The light behaves like a particle. Here light behaves as a particle nature, as a particle, and follows a rectilinear propagation. So light will travel in a straight line, no bending, no nothing, right? Is it clear, guys? इतना समझ में आया? So if the object is very big, then light will behave as a particle and it will follow rectilinear propagation. But if the size of the object is very small as compared to, or size of the object is very small, or can I say comparable to the wavelength of light, For example, around sharp edges. Sharp edges of the object. Then what will happen? Light will no longer follow its rectilinear propagation wala property, and it will start. एक second, let me just take the diagram from internet. Diffraction phenomena image. एक second, guys. Shadow. So guys, can you see this diagram? Can you see, guys, if there is an obstacle over here, this is the point source. The point source, the light shall follow what path? Can you see? It shall follow from A to C, right? Can you see? This is a straight line from A to C. From S to D, it's a straight line. From S to C, it was a straight line. But if you place an obstacle over here, and let's say, this is what, the here is the shadow region, and here is the illuminated region, guys. You understood? Which case am I talking about? I'm talking about this case. This case I'm talking, right? एक सेकंड रुक जाओ, मेरे को थोड़ा सा क्लियर डायग्राम ही लेके आने दो. Copy image, delete this. So guys, can you see over here? This object had sharp corners. Can you see? Yes or no, guys? Can you see this A and B is basically very sharp, right? The point source, can you see the point source? This is the straight line going from P to C. This is a straight line going from P to D. But can you see what happened to the light? Light, in spite of going straight, it bent into the shadow region. Can you see the light came into the shadow region? The light basically from here to here it came. Because of this particular sharp edge, it bent into the shadow region and moved towards D dash. Can you see it moved from the illuminated region to the shadow region? Yes or no? Here there will be the shadow region from C to D. Shadow region was there, but light entered in the shadow region. Can you see, guys? Here also the light, it entered into the shadow region. So can you see the light? It bent from its usual path. Yes or no? Now the new shadow region is basically what? What is the new shadow region? Is basically C dash D dash. Guys, are you understanding what exactly I'm trying to say? थोड़ा बहुत समझ में आ रहा है क्या? Initially, what was happening? If the size of the object, if it was a regular sized object where there was no sharp edges, no nothing, then the shadow region would have formed normally, just like that, from C to D. But what did I do? I sharpened the edges of the object. When I sharpened the edges of the object, now what happens? Now the at this point A and this point B, the light, it bent into the shadow region. The light bent into the shadow region because of the sharp edges. This phenomena is basically called as what? Diffraction. समझ में आया क्या? Guys, understood? The definition क्या बोल रही थी कि whenever light passes through the edges or the sharp corners of an object, it flares out in the shadow zone. So basically light bends into the shadow zone when it passes through around the edge of a obstacle. Can you see? It bent into the shadow region. Here also what will happen? See, the light would have followed a straight line path. But if I made this slit very small, if it's a barrier with a very narrow aperture, then what will happen? This light, in spite of going P to R, it will go to P to R dash. So can you see, guys, again, light was from here to here, it was shadow region. From here to here, it was shadow region. The light now entered again into the shadow region, right? Is it clear, guys? Are you understanding this particular thing? Guys, are you able to understand this particular thing? This light, whenever it passes through the corner, it will bend, and it will bend always into the shadow region. So what will happen? Your uh, shadow region will not become a illuminated. अरे यार मेरे को इतना सा एक बात बता चलो
So
suppose
here, why are they showing the path of light as dotted lines, and then there is also an arrow?
which arrow ये which arrow am I talking? This arrow, this one.
Yeah,
ये
yeah.
वाला ये actual नहीं है. This is not actual. It should have passed like this. But can you see the wavefronts? The particle nature says it should have gone straight, but the wave nature says no, bro, no. Can you see the wavefronts?
Yes, sir.
So the wavefronts, they have entered into the shadow region. So that's why. Can you see the wavefronts? They are entered into the shadow region. Wavefronts entered into. Can you see this? Can you see this? वो दिख नहीं रहा है, but they are there. Are you getting my point? So basically, this phenomena is called as what your. They have mentioned everything like single slit, CDs, geometrical shadow, PQ, ये है वो. Anyways, draw this. This phenomena of bending is called as what? I'll explain you the diffraction phenomena by Huygens wave principle. है ना? Don't worry. I'll show you video यार एक काम करता हूँ ज़्यादा पता जाएगा. Guys, let me share you a screen. एक second. Whenever you're done with the diagram, just tell me. I'll show you one video.
So can you scroll up 1 minute?
Guys, are you done with the diagram? If you are done with the diagram, then I will share, show you this video. Just tell me whenever you're done, है ना?
Okay, so done.
Diffraction of light waves through an aperture. In our earlier session, we have learnt about diffraction. Now let
एक
us
काम करते हैं. Let us learn about the diffraction. कौन है भाई ये? 7 active students है ना? एक सेकंड है ना?
the focus. Oh, oh.
चलो यही जाने दो. ठीक है, कोई दिक्कत नहीं, ये देखता है.
Now let us learn how the light.
Guys, see very carefully है ना? हो क्या रहा है basically? These are your plane wavefronts. Can you see plane wavefronts, guys? Hello?
So it's just showing the title.
It's just showing the title, मतलब?
Waves get.
The image is not moving or what? Image नहीं चल रही क्या?
So I cannot see.
एक सेकंड. Everyone can see this thing right now. Guys, are you
Yes,
able
sir.
to see this?
So now we
Now you
can
can
see.
see, right? ठीक है.
Diffracted at an aperture.
हाँ. So guys, can you see over here? These are your plane wavefronts. Is everyone able to see the screen, right? सबको ये दिख रहा है? Can
Yes,
everyone?
sir.
Everyone is able to see the aperture. Everyone is able to see the plane wavefronts, right?
Yes.
So now see very carefully, guys. Ki when these plane wavefronts, they will fall over the aperture. See what will happen. है ना?
Now let us learn.
I will show it to you in a very. Guys, look very carefully. Na? I have started playing it in 0.25 speed. Can you see over here? Plane wavefronts coming, plane wavefronts coming, plane wavefronts coming. When they hit this aperture,
Sir?
huh?
So I cannot
Sir?
see.
Yes, sir. You
Yeah.
can't see the diagram.
You cannot see the screen. That's what I was asking. No, can you see the
So
aperture
it's
and
stuck now.
No, sir, it's stuck in one thing.
it's stuck at one place? Okay. What to do now? Maybe इसको बंद करने के बाद stop share. I can't even minimize it. It's recording, no? So I'll try to show it again. Tell me, is this working?
Sir.
Is it working? Was the video
Sir, it's
working?
not moving again.
Not. नहीं, अभी तो मैंने pause कर दिया. If I don't pause it and then let it, play for a while. Is it moving?
Sir.
Whenever I'll stop it, I'll say कि I have stopped it, है ना? I paused it.
Diffraction. Now let us learn how the light waves get diffracted at an aperture.
Guys, I'm pausing it, है
According
ना?
to definition,
I have paused it, है ना? Hello?
So it didn't play for us.
Sir, it didn't play, sir.
अरे यार, एक काम कर
So
रहा
can
हूँ.
you share your desktop itself?
I can share. मतलब पूरा स्क्रीन शेयर करूँ क्या?
Yeah, if possible.
ओके, एक सेकंड. इसमें टेक्नोलॉजी यार. Screen share. Can you see the screen now?
Yes, sir.
Yes, sir.
the bending of a
Is it
wave
moving?
or its deviation
Yes,
from
sir.
Yes,
the
sir.
original direction
ठीक है.
of propagation
अब देख. Guys, see what exactly is happening. Can you see the plane wavefronts are falling from the left hand side of the slit? Yes or no? If this slit would have been a little bit bigger, this slit would have been bigger as compared to the wavelength of light, then can you see, guys, these wavefront would not have changed the shapes, है ना? These wavefronts would have still remain plane, but only this, like this. I cannot draw anything over here, but can you understand this particular thing? Can you see my mouse? Pointer.
Yes, sir.
So it would have moved like this, exactly in a straight line, and it would have fallen over here. The light from this point would have fallen exactly over at this point. So only this much part of the light would have been illuminated. There would have been a shadow zone over here and a shadow zone over here if this diameter was big. Okay, but what happens if I if I make this diameter very small? Matlab, suppose this is very small and this is like a slit, है ना? So if this is a slit, then can you see these corners, guys? These corners will become very sharp. If it's a very thin object, very nicely cut object, then the corners becomes very sharp, right? They are so much thin that they are comparable to the wavelength of the light. If they are comparable to the wavelength of light, then can you see, guys, the light ray has bent like this. Can you see? So earlier the shadow region was starting from here, now the light ray has reached over here. So can you see the light has entered into the shadow region? Similarly, on this side also the light has entered into the shadow region. So can you see, guys, the wavefront which were plane initially, now these plane wavefronts are now what? Spherical in nature. Yes or no? These spherical wavefronts, and if you remember, guys, spherical wavefront mein how do you draw the light rays, hai na? So can you see, guys, with the help of wavefronts I am explaining you this particular thing. The light rays have they have entered into the shadow region. This phenomena is basically what? The diffraction. So can you see, guys, according to definition, the bending of a wave or its deviation from the original direction of propagation when it meets a small obstacle or basically a sharp edge is basically called as what? Diffraction. Clear? I'm playing it again, hai na?
when it meets a small obstacle is called diffraction. The wavelength of the light waves is 5000 angstrom, which is very less compared to the wavelength of the water waves
Sir?
and sound
Hanji?
waves, which are
Sir, it's stuck again.
No, it's not stuck again. It's playing. Can you hear the sound this guy is telling?
Yes, I can hear.
So read the whole thing. That he is reading till here, the wavelength of the water waves and sound waves. है ना?
about few centimeters to meters. As the wavelength of the visible light is small, comparing to the wavelength
Can you see, guys? If you made the diameter of the slit very small, जितना ज़्यादा you can make it fine, the more the bending phenomena will take place, right? Yes or no? More the finely cut slit is there, more bending will be there, more entering into the shadow region will be there. I'll draw each and every diagram, don't worry about it,
of the incident
just
waves.
watch the whole video.
Hence, for experimental observation, diffraction of light waves needs small-sized obstacles. As we learnt earlier, according to rectilinear propagation of light, when light falls on the opaque object, geometrical shadows of small opaque objects should be formed. But as the obstacles are small, the light wave bends along the corners of the obstacles and slightly spread into shadows, and thus they are not sharply defined. In the case of monochromatic light, when the light wave is incident on the small object, like hair, or a sharp edge object, like blade, due to the geometrical shadows are formed with dark and bright fringes. Thus, diffraction is defined as the bending of light waves around an obstacle whose dimensions is comparable to the wavelength of the incident light, and hence its spreading into the geometrical shadow.
Alright guys, एक second.
Its spreading
हाँ, can you see this? Hello guys, can you see the right hand side of the screen? Yeah. Can you see
Yes.
guys?
Yeah, yeah.
Can you see this is the more illuminated part, and can you see the intensity is decreasing, and here, from here the shadow region is there. Can you see here the shadow region is there? Are you getting my point? The blackish region over here is basically the shadow region, and can you see the light has entered into the shadow region? Can you see? The light should have gone like this, where the intensity is maximum. So can you see a bright light over here at the middle? And can you see the light when it enters into the geometrical shadow region? Can you see fade amount of light is there, fade amount of light is there. So even the darkness is not there, but even it is not completely bright. Are you getting my point? This is happening because of bending of light. So kabhi bhi, due to the same phenomena, if you have let's say one, so suppose due to the same thing, if you have like एक room है, suppose there is a dark room, and you uh, have a door in that dark room, suppose, and let's say there is a lamp over here or tube light over here. So guys, tell me this particular thing, if there is
So
a
can you
lamp.
reshare your screen?
I can reshare my screen, no problem. पता नहीं, I don't know why it is giving so much problems now. एक काम करते हैं guys, hello sir, it's stuck for me at diffraction, can you share the video in the group? हाँ, I'll share the video, don't worry, I'll share the video link so that you people can see it. Oh, I don't know what is happening today, it's giving some problems. Can you see the screen now?
Yes.
So suppose there is this dark room, and let's say there is this door, है ना? Now tell me, suppose if I have a lamp, or basically there is another room which is attached to it in which there is light, but here it is dark. So if light would have not bent into the corners, then you would not be able to see, only this much part of the room would have been illuminated. This would be illuminated, and the rest of it should be dark, right? But have you seen this thing? Ki when you enter a completely dark room, if there is light coming from any particular source, even a small amount of light you can see, it enters into the room, and you are able to see the dark, the objects in the dark room, right? Yes
Yes.
or no? वो क्यों होता है? It's because of the diffraction phenomenon. Because light, it bends around the corner. It's not necessary. Light does not have particle nature only, no. So the light, it bends around this particular thing, bends around the corners, and due to which what will happen? due to which what will happen guys, अभी मैं फिर से बना देता हूँ, एक काम करता हूँ, suppose this is the case and let's say the light is coming like this, plane wavefronts are coming. Now can you see these waves 1 and 2, they got stuck. Guys, I think Zoom is giving me some problem. You know, it's not or maybe my PC, दोनों में से कुछ है, because it's running very slow.
So I think our screen is frozen actually.
तो एक काम करते हैं, you know, let's do one thing, we will continue again in the next class. Let me just check what is happening with this laptop. I think some problem is there, because you know it was happening in 9th grade as well. Thought, I don't know what is happening. Anyways, जाने दो guys, कोई दिक्कत नहीं, we'll continue again in the next class. Some issue is there, let me correct it, let me see what I can do to this, है ना? एक सेकंड, देखो फिर it froze again. Check the background apps running. Okay, एक सेकंड, let me stop the recording, है ना?